Check, check, check. Mic test. Good morning, man. Come on in. All right, start. I'm you. Big ball. Huh? Yeah. All right. All right. Take your time. I'm gonna go ahead and start. Good morning, everybody. Um, so I did get back the assignments. Although I haven't. I usually post kind of example solution. Holding back a little bit on that. Looking for some one or two more submissions coming in. Although I'm going to review maybe for 5 or 10 minutes here. So first assignment. Um, just to mention a couple of common things on the ones that I did get back to people. So, kind of reminders of where we're at. We're past the first assignment. We are working on assignment 2. We're probably going to start with that today. And really, also, we're kind of looking at chapter 2 this week from our textbook, which is kind of a big end-to-end example of doing a data analytics, data science kind of a project. And with that kind of in mind, I also want to mention I did post a deadline, and you should be able to access the link for the setting up your class project. So I think I mentioned this, hopefully I mentioned this a little bit. I am going to ask you guys to pick a data set and to basically apply a data analytics. So do some analysis, some data cleaning, that kind of stuff, and then maybe build a regression or a classification model on some data. So I am setting one deadline to accept this and to pick a data set by the end of next week. So if you haven't seen this yet, hopefully you can click on that link to go to the thing here. The project, this what I call the class project or the final project here. It's maybe not as big as some final projects for some classes. I'm going to weight it about worth 2 of our regular assignments. But I'm hoping that you'll do something similar to what we did on our assignments. So you do have a repository. You need to do your work in the repository like you did on the first assignment, like you'll learn how to do on the rest of the assignment class. But it is open, so you have to pick your data set. You have to add your own notebooks, add the code and stuff for the analysis, things like that. I can talk more about that, but for the next week, this week, next week, do make sure you accept that. Make sure you start thinking about, if you don't have a data set in mind, maybe look through those and try and pick something. So by the end of next week, I do ask. So basically, what you need to do on this, when you accept this, accept the assignment here. You can do the same things like you did for the first assignment. So once you've got the repository accepted, you should be able to find it. I think I keep forgetting to mention the class here. I know people keep hitting this. So sometimes when you accept the assignment, you get some kind of an error message about not having repository access. I'm not 100% certain why it happens sometimes for some people. If you do see that message, go check your email. So whatever your email is that you have connected to your GitHub account, it should send an email so that you have to go check that and put a link to do the final acceptance to get access to this repository that's owned by my organization here. If you don't see that email, you should be able to go So you find your repository, go to your organizations, look for your 574 Spring 2026 organization, which, you probably only have one organization here unless you've been doing other stuff on GitHub like this. But yeah, you should be a member of this Spring 2026 organization for this class. And when you accept the repository, if it hasn't granted final access on here yet, I think you'll also be able to click on a link here to get final access. So you can try that if you don't see an email. All right. And by the way, that's how I normally get back on my repository. If I don't have this link here after accepting it for the first time. So what I started saying for next week, what I'm looking for is that you basically just modify this README. So you need to make at least one application to make a commit here. So you have to open up the main README on the top level of your project once you clone it, and tell me what the data set is. I suppose you might have your own private data set or something. If it is online, give me the URL. If it's not, specify how you're going to make it accessible to me. Like you're going to put the data in your repository, or you're going to set up a link to it, or something like that. And then give a little bit of a description of your understanding right now of the data set and what you hope to do with it. Okay. So you can actually edit these. You can actually edit anything directly in GitHub usually. You could just edit this README directly here, or you could do the normal stuff. So I'll just kind of show that. Actually, they won't do that because I'm still. But you can clone it, and then this README.md file will be in your home directory. You can edit it there and create a commit and push it back up. So, okay, any kind of questions? I'm looking. I'm going to give you two things. I was originally thinking to have this thing done by the end of this week because we do have a second assignment which is due next week, but I didn't kind of get it announced fast enough, so I will give you till next week on that to pick a day set. But yeah, that does mean that we will actually have two things next Friday. So get this done and also get the assignment 2 worked on and done next week. Let me show. So yeah, I've got my container right for my solution here. So this is a different, this is my assignment 1, but the same thing. When we clone the class project, if you clone it, pull it down, this README file in your top level is the same one that's displayed here on these GitHub projects, and usually for central repositories like this, so Bitbucket and others do the same thing. Right? So you can also just open and edit the README here. These Markdown files. Markdown is, I don't know if people are familiar with Markdown. It's becoming pretty standard way of writing lots of documentation in in this kind of space. Working with Git and repositories and things like that. So it's becoming kind of primary way to write. So Markdown is a markup language like HTML. If you're not familiar with it, it's kind of lightweight markup. So you can do things like bullet points, and it might be good to read the basics. Hopefully I have like a link on that in my additional resources for the class, or you can just Google like basic Markdown. So yeah, any questions on that? But for a lightweight kind of thing, you could just edit it directly in here. But yeah, again, this is Markdown here. So, for example, URLs or in this format where you give shown and you give a link between the open and close parentheses and other stuff. So, I forgot. Sorry, my online people. I forgot to switch my desktop. I keep doing that. Okay, so yeah, I was talking about. I'm just looking at my GitHub account. If you're joining me after the fact on a live stream here. unless somebody wants to ask something about that, yeah, keep that in mind. Um, so yeah, my plan after reviewing assignment one is we'll get into probably actually then look at a little bit of assignment two, and also look at kind of the some of the chapter two stuff. I do have a lot of videos on this. If you haven't seen, been using these things, so there are basically the chapter two broken up into 2 or 3 different videos, different parts. Oh, and not to mention, also mention, beginning to think about the assignment two. I do ask you to do some stuff with stats model, which is another library like scikit-learn, but we're doing like statistical analysis on data sets like NumPy arrays or pandas data frames, but it's more geared towards kind of classic statistics rather than machine learning, if you're not familiar with it. But yeah, we don't really have that in the textbook, so I do have some videos and some links to some online sites, so you can read about the basics for stat models. I'll talk more about that this week and next week while we're thinking about assignment two and going through this chapter two of our textbook. All right. So let's move on. Let's go ahead and move on. Like I started saying, I did. I don't want to spend too long. Maybe I'll review on the same solution. If anybody needs it, I probably will post, an example solution notebook and an example solution assignment tasks in a bit here. But I did get feedback from most people at this point. I will mention. I was going to maybe mention again, like some of these functions that you did. If you're not familiar with these, the sigmoid and the sigmoid gradient, we'll be using these as part of our loss functions for logistic and linear regression. We talk in more detail about those. But those should have been as easy as kind of one-liners, pretty close to one-liners. Hopefully I didn't. I tried to spot check, but I might have missed some people. You should have been reusing your actual implementation of sigmoid to do. This is all you need to calculate the derivative of sigmoid. It's just the sigmoid times 1 minus it. Gives you the derivative. So we'll talk. Actually, the chapter 2 gets into a little bit about data cleaning. One important thing for data cleaning is scaling your data. So many machine learning algorithms are sensitive to the scale of data. So the features, if you have one feature that ranges from 0 to 1,000 and one that goes from 0 to 1, that can cause problems for some machine learning algorithms, like linear regression and logistic regression can be sensitive to feature scales being different. So easy thing to do. And again, the one that I looked at, pretty much everybody had the actual implementation of all these correct, which is why I'm not spend a whole lot of time on these. So this is called standard scaling. All you do to do this in a vectorized way is find the mean, and this little special thing here means that I don't want the mean of the whole two-dimensional array. I want the mean in a column by column way, right? So normally, I have mentioned this before, but when we use data in this class, we're pretty much always going to be using a two-dimensional table where the rows are samples of items and the columns are going to be features. So column 1 or column 0, we'll usually number stuff starting as 0 indexing. So feature 0, feature 1, feature 2, to feature n. And we have some number of samples 0 to m. Right. So this is a vectorized way. It's taking the mean column by column wise, as most people do correctly. And this also does the standard deviation, and scale every individual feature for, we're assuming this function that we have a two-dimensional NumPy array is passed in, right? 2D tensor. And this is all you can do then to subtract from the mean, centers everything so it has a mean of 0, and dividing by the standard deviation changes the scale so that everything has a standard deviation of 1. Another popular scaling is you scale everything between like 0 and 1. So our technical calls it the suspect read through check to so I did give a few comments to some people about so I do require that you always have function documentation for all so these are called Python doc strings. So it's common for lots of projects like this as part of the style guidelines. We need to document like every function or most every function except for maybe trivial functions or things like that. Right. So this uses a particular format, NumPy format. Again, I should have given a link. At least there should be a link in the feedback that I gave you, even if you did remove this. But yeah, some people were kind of deleting that out. So keep those in, and maybe for some future assignments, I might not give you those. You need to actually create the Python doc strings in this format. The description, you're supposed to, the NumPy style works basically like this. Hopefully I have this right here. Where you document input arguments, and then you document return values. It's kind of pretty standard for this kind of function documentation. So, if you're not familiar with the way Python works, these are actually available to you. So if you're using other libraries that you're not familiar with, so let me go ahead and open up my Jupyter Lab here. Log in, use my token. So let me open my notebook here in Jupyter Lab, and rerun it. So another note I gave to some people is, so for this assignment, I really didn't have tasks you had to do inside the notebook itself, except for just run, so after you complete a function, just run these to make certain that the tests were passing inside of the function. But I had a couple people were not actually, looks like weren't using the notebooks. So I can tell that so I look at your repository and no commits have actually been made to change your assignment notebook. And if I go back and look, so you can change to, sorry, I'm going to change to my different repository here. One I'm working on. So, you can kind of look at what the most recent committed version of any of the file is, assuming that GitHub knows how to render it, like plain text or source code or something. So, I mean, a lot of people actually hadn't run the notebook and added it to a commit, so when I look through here, everything is still failing, or they'd only done a few things, but hadn't done it for the last couple of tasks that they'd done. So, didn't make a big difference on this one, but again, in future assignments, there might not only be that you have to complete some tasks in the source, the assignment task.py file, but there'll be cells that you need to do in the notebook to do things, like create figures usually, or other stuff to use your function to trace. So I will be looking at you are actually using notebooks and running these as well, but those will be added to your commits Anyway, so if I gave you a comment about that, that's what I was talking about. Your notebook looked like it wasn't actually run. So, let's see if I can get this to run here. This should, I'll check. I think I fixed the stuff on assignment 2, so you shouldn't have to worry about the Python path going forward, I hope, for future assignments. You have to work. So I started to say, so for example, if you have the Python documentation, so a lot of high-level languages do similar stuff like this. You can use this to introspect to get the documentation for the function. So, like in your Python notebooks, we can do something like look at the show contextual help. So here, whenever I'm in the context, it sees wherever you got focus, and so here my basic function will pull up the documentation, the Python string. Actually, I guess it's pulling up the full function here, but yeah, that's one thing. You can also use just help directly from like a so this basically, if you're working at a terminal session, so in Python, you can just use the help function or use the Python documentation. So anyway, I use that a lot personally. So you may or may not, but that helps be a little bit faster than having to go Google stuff. Sometimes you can just directly get the basics that you need. That okay, here's the basic idea of what the parameters are, and what I need to do, and what's going to return. Although not all libraries have good documentation, so a lot of the built-in or basic stuff like so some of the basic libraries might not have documentation either. Some do. Okay, there's a little bit of a side. Sorry, all right. I was going to mention on the one encoding. There's also another thing you haven't read chapter 2 this week. Talks a little bit about this is part of data cleaning. So I already kind of described this when we were talking about doing the assignment 1. So some types of features are categorical, but just converting them into an integer 0, 1, 2, 3 doesn't work as well for some machine learning algorithms than using separate columns in 0 or 1. So by through categories, what this is supposed to be doing is changing from the 1 feature into 3 features, and each one represents one of the 3 categories. And only one of those would have a 1, and that one has categorization, the other would be 0. So I usually say, usually you should try to avoid loops. I forgot to mention for this one, when you're done cleaning like this, usually it's not, performance isn't as important as, for example, like your loss functions and things, which need to be very efficient because they're called a lot in order to fit like a model with some data. So the stuff you do up front to get data formatted so it will do the best when you're trying to build a model or something. Don't necessarily have to be as efficient, So vectorization is work like we're doing the one encoding. You're cleaning and analyzing your data. So a straightforward way to do coding would be with a for loop, although I did notice, maybe since I forgot to mention this, some people, you can't do this in a vectorized way. It's a little bit complex. So the basic idea is with the loop is that each sample we figure out what the category is, and we explicitly set the value in that column or category. This example solution for Post-it, and that's what it's doing, but we're using explicit loops to start with vectorize. So I should probably add in an example of doing this using just NumPy functions. You can, some people did figure out how to do that with NumPy functions. It was great. All right, then again, I don't think these the ones that I finished. Anybody had gotten the root mean squared error, the absolute error. So if you don't know what these are, we will go into some details in a bit on the importance of these kinds of loss functions and how they work in machine learning. But for right now, most people have this correct. All they're doing is giving you a measure of how close some set of predictions are to a set of labels that you have. Right? So they give you one number that, and it's actually just a little bit about loss functions here. It's actually a minimization function. So because of this difference, if all my predictions are exactly equal to the label, I'm going to have no error, zero error. Error would be zero. And the further my prediction is away from the true value, like for a regression problem, the more error I have. So you'll get things for a root mean squared error loss function. Since we're doing a square, you actually get a loss function that's a parabola, that's smooth shaped like this, some minimum, which can be zero. For some problems, we have some noise. It might not be possible to build a model that can get the error down to zero. But sometimes there'll always be some minimum, even if you have noise in the data, that you can get to. And less good models will have a higher error. So for this function, and you get a similar one, but like a different shape, if you do the absolute value instead of the square root. But yeah, for these, you can tell whether your model is as good as it can be by calculating the derivative of your loss function and following it towards places on the loss function or the error here that are smaller than what I'm currently at. And again, if that's not making sense to you right now, hopefully, when we get in kind of details of this, when we begin talking about linear regression, this will make more sense. This kind of stuff. If you've ever looked at optimization or minimizing a function like this. But this is the type of optimization problem where we set up a function that we're trying to optimize, trying to minimize. Okay. Yeah. Final thoughts on that. Let me know if anybody wants to ask anything. But do check the feedback pull request. So some other stuff that I had to tell people about. So for one, do not close these. So like it says here, do not close feedback pull request or merge your commits from where you did it, impacting the feedback and main. So this is the main way that I evaluate your work. So if you leave the stuff the way that the GitHub Classroom sets it up, basically, I see your commits. I can look at individually what you did commit by commit. So another comment I gave, is it is a requirement to give commits for at least each task. I might even make a requirement like if I have subtasks. So this is also kind of standard best practices. You should commit early and often when you're working with a revision control system like this. You want to have commits that are related but relatively small, and lots of them. So for one thing, these are kind of like a backup, right? So if you make a commit, you get pushed to Git. If your system crashes or something, anything on GitHub, assuming something catastrophic doesn't happen with GitHub, it's safe up there. It'll be in your repository forever at that point. You won't lose it once you've made the commit, pushed it up there or something. But for me, this helps me. If I need to, I can see the thought process and the work process of students, how they did stuff in small steps. Not to mention, I can also see when they were working on stuff, how long between things that they did from the timestamp on commits and things like that. So it is a requirement that tasks, maybe even subtasks, should be done as individual commits. Try and get good commit messages, so at least a title and then a description for the commit. And so don't close or merge these. So if some people are familiar with using Git. Git in the classroom kind of sets up pull requests kind of the reverse of the way I would normally do it. So you should always, for these assignments, you should always just be working on what's known as the main branch. So don't create or go to another branch when you work on these assignments. Just always make commits on the main branch and push them back up to the GitHub repository in the main branch. So the way that these feedback pull requests are working is it creates a feedback branch, which is branched from the commit that's made, the last commit that's made, actually the one before this, before you start working on the assignment. And then it does a difference between the stuff you push on main that hasn't been pulled over to this feedback. So that's why anything you push to here that hasn't been merged or pulled over to feedback yet will show up here as individual commits. So if that doesn't make classes to you, just remember, always work on the main branch and always push your stuff to the main branch for these on classroom assignments. Okay, so I think, all the general stuff. A lot of this, I won't necessarily take off points, although, if you're consistently not doing, like, these things that I ask you to do, if you just do all your work as one commit going forward, I might revert that and make you redo it. Or, if you're not giving my Python documentation, I might not evaluate your work until you get that stuff added in. That kind of stuff. So, and those requirements are just, if you ever do go off and are working in an environment, a company or something, there will be standards that you'll have to do, the way that people want things done. So, and just in general, learning how to work on a project, that you're following best practices, following the requirements for creating code and making commits and stuff like that. All right, I think enough about the assignment one. Somebody wants to ask something about it before we move on. Okay, good. So let's go ahead and move on to some stuff, I guess. Close this stuff off. So I will probably post some example solutions for that future, although I don't know anybody really, it was the ones I looked at, will really need to look at that too much. Okay. I was probably going to talk a little bit about the lecture notebooks for chapter 2. So this will be a little bit redundant, a little bit overlap with some stuff from the videos here. But yeah, let me bring that up first, but I'll also maybe need 10 minutes to clone the assignment 2 and at least get a first look at that. Talk a little bit about assignment 2 available here if you haven't found it yet. So if you haven't accepted the assignment, again, I always encourage also people to accept the assignments early rather than wait until Friday, like I had 1 or 2 people do even on this first assignment, just to make certain that you are in the repository and just check that you don't have a technical problem with things. So yeah, let me remind you about using these lecture notebooks. So I won't recall the repository, but all these lecture notebooks, the one I'm going to look at now, you can find on the additional resources. Looking at the repository for the 574 machine learning class, right? So you can clone all of this material. You'll have to use the HTTP URL to clone it, so you don't have SSH. You don't have direct access to this, but you can clone this, get it down there. It should have a Docker container set up, so you should be able to do the same thing you do with the assignments. To look at these notebooks. So, I don't know if there's anything we might want to go back and talk about Matplotlib or pandas. I'll leave that. There is a little bit about plotting stuff on this chapter 2. So if you haven't gone over the Matplotlib materials, that would probably be helpful understanding some of the stuff that's being done with visualizing the data analytics kind of end-to-end project on the chapter 2. So let me go ahead and open up. Okay. So, same way, you can run these notebooks in VS Code, or it should be Jupyter Lab server running, although, again, it's not set up, so you will have to find the token in order to get logged into it. So, I'm only going to be able to get started on this one a little bit, so let me just mention on the first one. So there are kind of 3 different things here. So there's the first one is about visualizing. So this is really about data exploration. Okay? So this is also kind of relative to the stuff I hope you do on the final project, the class project. So you should kind of think about this if you're doing the same stuff as is described in chapter 2 here. So usually the first step on your data set is we need to gain some insights into what's in the data, what potential problems there might be, some ideas of what the features are, what the correlations between the features might be, that'll give us some ideas of what we might try to do, if we want to build some models, things like that. Right? So once you've done your kind of initial exploration, you move on to kind of the second step here. So once you have an idea of some kind of model you want to build a data set, you need to do some basic data cleaning. And you may or may not need to do this for your data set for your kind of projects. So a lot of the data sets in like those UCI repositories and things are relatively clean. There won't be a lot of missing data or things like that. So some big things on real data sets are often very messy. So there might be lots of missing values. I have to deal with those. There might be the feature scaling. There's another thing that's covered on here that we were talking about. Um, see, things like missing data. Um, Figuring out how you're going to handle. So lots of times you'll have features that are really textual. So you might have to first convert textual things into like a category or do something else with it to process textual information and other stuff. So that's kind of what the section 2.4 is on our chapter 2. Um, And then finally, so there's not a whole lot about actually building models doing machine learning. So really, except for this week, we don't really. This isn't really a data analysis class. So if you do get a job doing data analytics or something like that, which is something that is in pretty high demand. So people with a master's in computer science degree can aim for those types of jobs. But yeah, doing a lot of data analytics, usually actually spend most of their time doing exploration, cleaning, and stuff like that, and maintenance, right? So this class doesn't actually reflect what you spending a lot of your time doing if you're kind of in that sort of role after school graduation. We mostly focus on the stuff on the third here is okay. So you got a data set, it's kind of clean and ready. How do you go about building a good model that has good performance? Good performance in this context means that it makes good predictions. Given data it's never seen before, it can do well at predicting the way that categorical data or making a prediction of the value for like a regression problem. So anyway, that's kind of what the third section is about here. And so I don't think I have enough time to actually get into the specifics of any of those three. So let me go ahead and maybe for the last 10 or 15 minutes, let's just jump to the assignment 2. So I mentioned this in passing. There is another notebook on what I labeled B3 here, which is not from the textbook, but there's some stuff on the basics of scikit-learn. Actually, this is maybe what I should talk about today here, but also there's some stuff here about stats model as well. So you're asked to do a little bit of work using the stats model library, which really isn't covered in our textbook, so you have to pick it up from here or from some of the links that I gave. So let me go ahead and accept the assignment 2. And get this repository container created here. So oh yeah, I have to close off these notebooks if I do this. You want to do that yet? Yeah. Okay. So we'll go through the usual steps again. Accepting the assignment, closing the repository. Do that. Close that. create a container for us. We can run it in a container. I'm just doing this for one thing to check that I did get the stuff fixed, like the Python path. I think I removed the need to use the token as well. I hope I got that working here on assignment 2. Get a chance to check it here before today. So yeah, the press can take a little bit of time. So let that continue running here. Just look at the notebook on GitHub here. So so again, there's kind of two main tasks. And we haven't talked about linear regression or logistic regression or classification yet. Although if you've done the reading of chapter 1, there was a basic introduction of what we mean by regression versus classification. So chapter 2, when you read through it, is an example of doing a classification. No, it's an example of doing a regression task. So we're trying to predict the price of houses in a data set, a California data set on that one. So here, usually things like prices or anything that's a real value number is going to be what we call a regression problem. So we're talking about supervised learning for the first 2/3 of this course. So in that, when we have a data set, there's going to be, for each sample, there's going to be a label. Maybe sometimes multiple ones, but when I'm building a model, usually there'll be one label. So I want to build a model given the data to be able to predict those labels, right? So that's what the way supervised learning works. And so if that label is like a real value number, we're going to be doing a regression problem. And then next week we'll focus more on classification problems. So if the label you're trying to predict is something like true, false, or yes, no, that's a binary classification problem. So it's a category 0 or 1. You're trying to predict given the data. So on this assignment, the first task 1 is there's a data set. So the way most of these assignments work, we lay out the project using folders, subfolders. So again, like standard practices. So the notebooks will always be in the notebook subfolder, and source file like your assignment task will be in the source subfolder. If there's data to be used that you have to load and work with, it will be in the data subdirectory for these projects. So when you do your final project, you should use the same kind of structure. So you would usually a minimum have like notebooks, data folder, maybe other folders, depending on what you're doing on your final project. Maybe a source folder for common source codes that you might use. So let's see if my container's created yet. So I'm going to reopen this, but actually open it up in Jupyter Lab here. So here, yeah, if you see these things when it starts up the Jupyter Lab, token equals blank, password equals blank, that means that it doesn't need token anymore. So that's all you need to add to get the rid of the requirement for the token there. So once you have that, you have to open up the NoHub. You should be able to just go directly to your port 8888 being forwarded and get into your running Jupyter Lab server. And we check the path here. So, again, these notebooks should always run, all the cells should always run at the start of the assignments when I give them to you here. If I rerun all the cells, it should run, including if we've got the path set up correctly, it should get past that. So, yeah, now we should have the Python path set correctly now for these. So, yeah. So you should see that it will automatically set that for you. correctly now for this assignment and all the assignments going forward. With that said, another thing I don't think I've mentioned before, but you can actually run all the tests instead of running them from the notebook. You can run them directly from the VS Code. So the it's supposed to. So there is one thing missing here. So it's supposed to install have the test runner available. That should show up. I'm not certain why. You can run them from the command line. So if you run like the make command, it should run all the tests that are set up for the assignments. These will all initially be failing. But you should also be able to run that. I don't know why that wasn't set up automatically. I have to check that. So normally you should also be able to run these tests in the GUI test runner here if it sets up all your Python and things. I think an extension might be missing still here. I'll check on that. I find that convenient to be able to run them. Not have to use the notebook to get all that stuff run, to go back here and just check which tests are running or not that you do for the assignment. All right, so the last 5 or 10 minutes. So I started mentioning here. So yeah, this notebook should be running. So these cells that run the tests should run, although the tests will mostly all fail usually, but it should go past those even still run. Also, like this assignment, there are lots of cells that you're supposed to be doing stuff. So you do have to do 1 and 2 here to actually last stuff even before that. So you're supposed to load the data set here into a pandas data frame, and then do all these things. So basic data exploration, so number of samples, number of features, and report those on there. So on this assignment, I will be looking into actually run these tasks in the cells as well as complete the task in the assignment task.py file. So just be aware of those. This first one is using the assignment to weather CSV file. So also always be using relative path names. So when we're in a project directory structure like this, we're running the notebooks from the notebook subdirectory. So you shouldn't give like an absolute path name for like a load from pandas or something like this, so that if I move this somewhere else, your notebook will still run. Right? So relative from where we're at, the data file that you want to load, you have to go up one directory. So you have to use 2 dots to go up one in the directory structure, and then go into the data subdirectory, and that will get you to the assignment to web.cv. I can't remember if we're using these regression features and labels. Those might be dead data type in there. So, but yeah, we will be doing both regression and a classification problem on this assignment using this data set here, the assignment to web. So yeah, for task 1, you have to figure out how to load that data set into a pandas data frame, do these things for asked for. So I think on Thursday, just in case anybody needs it, I should go back and talk a little bit at least about using pandas data frames, using pandas library, as well as maybe matplotlib a little bit. So I'll spend maybe 15 minutes on each of those on Thursday a bit. So that was supposed to be last week, but we haven't really talked about that in class in case students haven't used those before. Um, so in the first task, I was just looking for it. I mean, basically, there are two features. So we're just doing a simple regression. We're doing the regression on to figure out the relationship between the temperature at 9 in the morning, or the evaporation temperature at 9 in the morning. Um, so here, this is a little bit arbitrary, just so we can practice doing using scikit-learn and stats model to fit what's known as a linear regression, fit a line to some data. If you've never done that before here, so the temperature should be your x variable, single feature for the temperature of 9 in the morning. We're going to try and fit that to do evaporation. So yeah, you're supposed to create a figure. It should recreate exactly this figure here. Right? So this is a class regression problem. So from temperature, we're trying to predict what the evaporation is going to be. So this ends up being the label that we're going to do for a regression problem here. And so if we assume that there's a linear relationship, so a straight line ends up being a good predictor, we can fit a line from this to try to predict evaporation. So linear regression is not how do you figure out what is the best line, what will give the best prediction, will minimize the error of the loss function. So in some sense, I talk about loss function in more detail, but in some sense, this line is the best one of any line that you get in terms of minimizing, getting the best predictions. So yeah, and also, so on Thursday, I'll talk a little bit about pandas and matplotlib, and also we should talk about the basics of stats model as well. So besides using scikit-learn, so kind of the goal on this is not necessarily to understand the machine learning algorithm, but just to learn how to use the scikit-learn library, and also kind of compare it how things are done slightly differently in the stats model library. So we do the same regression, but using stats model. So the same regression on the temperature and evaporation for this part here, just using the stats model library. All right. So yeah, there was like 4 subtasks in that first task. Some people were asking me about these. It does auto number these. I use these outlines a lot. And by the way, something else for me to mention. So it's also a good idea to be familiar with how these notebooks work. So not only code cells, but the markdown cells, the text cells. Right. So again, mentioning markdown. So markdown is used for if I want to have a cell that's textual information. If I ask you to write an analysis or describe something in English, give the results or something, you should use a markdown cell and use write your analysis in regular English using markdown formatting. Right. So the way you do that is go to a markdown cell and whenever you render one of these markdown cells, it'll render the markdown into that like bullet point numbers and enumerated lists and things like that. So, but yeah, the headers basically are what create an outline for a document like this. Level 1 headers for tasks 1 and 2, level 2 headers for the subtasks. We've got 4 subtasks. Task 1 and more than 4 for task 2. All right, and then just to finish up on that. So then the second part, we changed to doing a classification. So on this one, I have to remember here, but there is one feature which was whether it grade or not on a particular day. So that's a classic binary classification task. So on the second part for this assignment, we changed to doing binary classification, where the model we're going to create is going to try to predict yes or no at range using one or more of those features like temperature and evaporation and stuff like that. Again, using stats model, using scikit-learn, and then stats model. So using scikit-learn with a logistic regression. This is, I mentioned this multiple times. There's a thing called linear regression and a thing called logistic regression. We've never run across this before. Unfortunately, it's kind of confusing. This comes again from classical statistics. Linear regression is really what we would call a regression problem. Logistic regression, when we do logistic regression, that's actually an example of doing a classifier or classification. Just have regression in the name. So you just have to kind of remember that. It's just historical where that name kind of came from. All right. So yeah, that's it for today. I've used up all my time. I'll let you guys go. We've got plenty of stuff to talk about on Thursday. We'll continue on this. Those things I talked about, and then we'll try to get back to the chapter 2 stuff next week specifically. So if anybody has any questions about that in example